Please make sure you sign into the meeting so we get a larger room next time.
Before you come to the mic, please raise your hand. So, okay, welcome everyone to IETF115. We are so happy to see you in person. It's going to be a busy meeting. Please be on time. Please respect time of others, and let us open the meeting. If you haven't read it before, please read it. Not well by participating in IETF. You agree on everything that is defined in BCPs and text below. IPR disclosures. We've got a routing working group specific process. We require you to disclose IPR before document get adopted by the working group. We require you to declare IPR before document can go into working group last call, unless all authors and contributors have declared explicitly their IPR, document is not going to progress. Please make sure you do so. We haven't had any adopted working group document between two IETFs. Existing documents, the Jan Krieb extended, we closed working group last call, and Shepherd write-up has been uploaded, so we are waiting for AD to review document. BGP peak comments yet to be addressed. ATN BGP, there's some reviews been done, it's a long document. We expect to progress at some point, and there's also related drafts that are progressing in 6-man. TI LFA, Stuart, do you want to say a few words? And thank you again for doing this.
Only that, well, I apologize to the working group, this has taken such a long time to get there, but had a very productive meeting with the author team before earlier this afternoon, and I believe we got a way forward with the last remaining issues. So hopefully this will soon be with the IESG.
Great, and again, thank you so much for doing the work, and I believe after the upcoming update, we are ready to progress with TILFA. And QoS model will be updated today. So agenda for today, I'm not going to read it. Again, we've got busy agenda, please be on time. Agenda for tomorrow's meeting, and we are going to have guests from SIGCOM. We are going to get the best paper award presentation, and again, busy day. And we are ready for the presenter to come. Please do take a look at Wiki. We are start to populate data there, and all additional information will be hosted in Wiki.
Okay. So you'll be moving the slides, right? Okay. Okay, so hello everyone. My name is Asim Chaudhary. I will be providing updates on QoS model. Next. So in the latest version of the model, we have added one more module, which is INA cost types, which contains all the identities from the different cost modules. So essentially what we are doing is that we have taken the identities from the cost modules and moved to the INA cost type module, so that going forward, we don't have to change the cost modules, and we can simply change the INA cost type module, which will be a much simpler process. Also, in the last version of the model, we had included operational model. So in this version of the model, we have added the action statement to clear the cost counters. We have also added the security considerations. Also, there had been a lot of young doctor comments on regarding the different filters and how they operate or connect with each other. We have given an example in Appendix D, and in the next slide, I will be presenting or including how they are correlated. And it will be pretty clear from there that how the different filters correlate with each other to create classifiers. And in the policy model, how the inline filters are included to create the policy. So also, we have created a presence container for inline classification that has helped to include the, to get rid of the inline flag and has simplified the model for us. In addition to that, we have taken care of numerous young doctor comments, and based on those modifications, we are able to come up with a cost model 09. Next slide. So if we look into this particular example, it's an example for classifiers, and the name of the classifier is my classifier, and this is a filter operation match all. Now, what does that mean? That means all the filters need to be matching to the incoming packet for the classifier to be classified, for the packet to be classified under that classifier. And so when I say match all, that means it will be matching all the filters. And if we say match any, then any of the filter matching to the packet will be considered classified for the packet. So in this particular example, if we can see that we have included two filters. One is of the type DSCP, other is of the type source port. And if we look into the DSCP filter, there's a logical not as true. What does that mean? That means that whatever parameter which is defined under the DSCP filter, it will be the not of that. So for example, in this particular example, if the DSCP value is 11 to 13, that means, and the logical not is true, that means 0 to 10, and the packet, incoming packet, if it has DSCP value 0 to 10 or 14 to 63, that in that case only it will be matching to that particular filter value. If the logical not is false, then it will be matching for the value 11 to 13. Okay. Similarly, for the source port, we have multiple range values. In this particular example, we have source port range from 10,000 to 10,300 and 17,500 to 19,800. That means incoming packet, if it has source port range in these two particular ranges, then it will be classifying to that particular filter. So if we look overall classifier example, which we have presented here, that means an incoming packet which is coming has to match to all the filters which are defined here, and the source port value will must be in this particular range. And for DSCP value, it will be the reverse of the range. Now there had been a lot of confusion and a lot of young doctor comments regarding this one. We have not only provided the text to clarify this particular details about the classification, but also provided this particular example, which will help to clarify or to understand how the particular classifier behaves. Next slide. Similarly, this is a policy configuration example. And in this particular example, the policy name is my policy. And if we look further down, it has an inline container. Now that inline container means that the configuration parameter has to be defined inline into the classifier itself. Now, if we look into the various vendor implementations, we will typically see that a classifier has been defined as a template or has been defined as inline. Now, it also depend on customer requirements. I have personally seen a lot of customer who wants to segregate the classification into a separate classifier. And that way they are able to segregate filters with the actions. Now, typically the COS has much more complicated actions. And so they want to segregate filters with the action. And so they define the classifier as a separate template. But at the same time, I have seen a lot of customer who wants to define the classification parameter as part of the inline into the policy. For them, it's a simple mechanism to configuration of a QS policy. So it may depend on a customer requirement, number one. Number two, also for vendors, typically they support one or two format or even both. But essentially, if you look into this example, in this particular example, the classification parameter are defined in line for the DSCP value, which is in the range of 21 to 22. And if you look into the action, it's a marking down action from 21, 22 range to 23 range, to 23 value. And so for vendors to implement this, they may take these inline parameters and convert into their internal template implementation. Or they can, if they have a template configuration here instead of inline, and they're referring the classifier as a template, and if vendors don't support that, then they can take the classifier template parameters and convert into the inline in their internal implementation. Next slide. So essentially, we were hoping that we'll be able to cover all the young doctor comments by this IETF. But even despite we working very, very hard on that, we still have some comments to be taken care of. We are very, very hopeful that by next IETF, we'll be able to cover those. That's it. Questions? Okay.
Thank you.
So thank you for the progress. Really good work, and we are getting closer to working group last call.
Definitely, yes, we are. Thank you.
Hello, everyone. I'm going to present SRv6 pass egress protection. Next page. First, the author of the document would like to thank AC, Peter, Bruno, Yimin, Jeff, Zhenqiang, Chris, Alex, Keaton, and Greg for their comments and suggestions. 1 year ago, we presented this document and asked for working group last call, but we are suggested to have LSR working group to review this document. So we presented this document in LSR interim meeting, and we get a comment there. In addition, AC also carefully reviewed the document. We got available comments from AC. So in this current version, we address all the comments received. Basically, we remove one optional sub-TLV and some editorial changes. So that's the main updates to this current version. So next page. So we would like to have, ask for a working last course. Any comments? Welcome. Thank you.
Questions?
Any questions, comments, tomatoes?
Keaton, go ahead.
Um, since the contents of this draft majority is LSR and Spring related, and you said this has been reviewed in LSR, how about Spring review? Has it been reviewed there, because it defines a new behavior for the mirror set?
You mean for the Spring review? So in fact, yeah, you're right. Also, I think I remember you suggest we send this document to Spring Group for review. And as you suggested, I sent this document to Spring, ask for comments a couple years ago.
Yeah, I think at least before the last call, we still need some feedbacks from Spring. Yeah, so we'll try to do this
yeah, send
again.
document there, but I don't get any feedback from Liz.
Yeah,
maybe
so
anyone that has comments, and then
let's try again.
Try again. Okay, I'll try again. Okay.
Yeah, so practically there's a couple of documents that kind of share working groups. So protection, that definitely belongs here, while encapsulation and technology someplace else. And we'll be talking to Spring specifically to get more reviews there and make sure that it can progress here.
Okay, I'll try again. Okay.
So the next presentation is also covering the same topic. So.
Yeah, for that one, we answer the difference, the two equal protections. In fact, a different one. So maybe I just answer a difference here. Just answer some questions maybe further. So basically, there's
after that presentation.
After that presentation, yeah. Okay, okay.
So hello, Chao. Could you hear me?
Yes, I can hear you, and I pass the control to you so you can control the slide.
Okay. So hello everyone. I'm Wei Chang from China Mobile. I will present the draft on behalf of all the courses. So it's a little bit slow, right? So, Chao, could you help me control the
it's at the bottom
slides?
of your screen. You have the.
Yeah, I see that, but when I change that, how about it now?
It moved.
Oh,
yeah, it's working.
Okay, thank you. So the draft introduced a very simple multi-home protection for the ISAV6. I think it's different from the draft while more just present. This is on the VP level to provide some protection solution. So maybe Huaymo will give more his understanding. And the basic idea is that we introduce two new items. The first one is backup seed, which will be put on the top of the seed list. And the second item is a new flavor. We call that penultimate segment decapsulation flavor, which indicate the SR6 penultimate segment decapsulation processing. The basic idea is that when the penultimate endpoint receives the packet and fed that, its next hop direct neighbor is the egress node, and it's unreachable. Then the penultimate endpoint will direct the packet to the backup node based on the backup seed. So let's see the encapsulation of the backup seed. it will be put on top of the seed list. And let's see the PSD flavor. I think I just have mentioned that it will indicate the pentamate segment to remove the encapsulation and then forward the packet to the primary node or the backup node. The flavor will be applied to some VP seed, such as the N.DT4, N.DT6, and so on. We just need some minor change to the side code of the SIH processing, which defined in RFC 8986. As shown in this page, a sub condition will be added to S02 line. So we also give an example. The basic mechanism at the ingress node, it will insert the backup seed on top of the seed list. For the penultimate endpoint, when at the normal condition, the traffic will be forwarded to the primary egress node. When the primary egress node receives a seed with a PSD flavor, it will remove the encapsulation of the packet and forward the packet according to the payload packet header. And if the pentamate endpoint found the primary egress node is unreachable, it will modify the destination address of the packet to the backup seed directly. Then the traffic will be forwarded to the backup node. So the multi-homing protection will be achieved. So here is an example. We will ignore that. And compared to the previous version, in this draft, we introduce the PSD flavor to indicate the penultimate segment to remove the encapsulation directly. And we also change the position of the backup seed. Instead of the bottom of the seed list, in this version, we put it on the top of the seed list. So that's all. And any comments or questions?
Yeah, Darren Dukes from Cisco Systems. I hadn't seen the PSD SID discussed in Spring at all. Have you discussed that there? I might have missed it.
Oh, so this is a good question. Thank you, Darren. I think yes. We just presented the draft in RTG working group at this moment. I think if it's necessary, of course it's needed. We should maybe present the draft in the spring also.
Yeah, sure. Just and also just I mean, you could alert Spring of it at any time. Just send an email because I think we should probably talk about the impact of that SID type. Thanks.
Okay, we will.
This is Huaymo from Fuseway. So I just want to explain the difference between the two egress protections. So this one, my understanding is that this is for VPN, some kind of surface protection. So in order to provide this egress protection, so on the backup egress node, we need to configure the backup seed. So that backup seed share the same space in the backup node, right? And then the behavior of that seed should be mirror or same or similar to the seed on the primary egress node. So under this condition, at the egress node, and then we can put that backup seed as the last seed in the seed list, and then we can achieve the egress, achieve the node protection. So our approach is that, so our egress protection is a normal egress protection. So all the seeds on the primary egress node, so we don't need a configuration on the backup egress node. So we use a mirror seed as a context, and then all the behavior of that seed on the primary egress node, we just mirror to the context node of a primary node, and then we use that table to forward the package to the destinations. So that means it's different from different approaches. One is focused on surface, and one is for normal protections.
Okay, thank you, Huanmo. I think yes, the both draft is different. I think it solves a different problem at a different level. So thank you.
Ron? Ron, you there?
Can you hear me now?
Yes.
I have a few comments on this work. First, it's laudable. It is a problem that needs to be solved, but there are a few impediments. First, along with bringing it to Spring, you probably should bring it to 6-man because it changes the semantic of the SRH. Second, it does change the meaning of fields in the routing header. How do you intend to maintain backwards compatibility in light of that?
Okay, so thank you, Ron. Yeah, firstly, I think I agree with you. We not only need to ask for the comments from the Spring, we also need to do the same thing in the 6-man working group. And the second question, I think the current solution is compatible with the SRH processing rules. I don't think we introduce some new, but anyway, we should.
Haven't you changed the semantics of segments left and last entry?
Oh, yeah, correct. We introduced a new flavor for that. I think maybe the flavor can be used at that scenario, right? Because the flavor can indicate the different.
And finally, one more question. How does this interact with the CSID?
Hello?
Yes, one final question. How does this interact with CSID? Can you hear me?
interrupt.
We lost him. Yeah. We lost the.
Can you hear me?
No, we lost the presenter. We'll give another minute to reconnect, and otherwise we'll take all the questions to the list.
Okay.
And obviously this needs to be discussed in Six-Man and Spring.
Let's do the next one. Then.
Yeah. So if you reconnect, we'll try to do this if time allows. If not,
hello, Charles. Could you hear me?
Yeah. So last question from Ron was, how does it interact with CSID?
Okay. I just was lost due to the band network.
Did
now
you
I
hear the question?
I did not hear the question from Ron. The last question, I did not hear.
The last question is, how does this interact with CSID?
I think this moment, you know, the CSID draft can support the mixed comprised seed and the normal seed. You know, this flavor just for the VP seed. So when we keep the VP seed as a normal seed, there's no any other problem. So I think it's compatible with the CC draft.
Ron, does it answer your question?
Not probably better bring to the.
Yeah.
Yeah, I think it might require a little more discussion.
Okay. Yeah, it definitely requires more discussion. Keaton?
And maybe after the meeting, we can do more detailed discussion. Yeah, please go ahead.
Ketan Talaulikar, Cisco. I had actually a question on slide number 6. If somebody could bring that up, please. So this slide talks about this slide talks about penultimate node. Now, when you say penultimate here in this example, the SRH has A2::1. So do you mean the penultimate endpoint, because that could be several hops away, or it could even be the ingress PE when there is no SRH, right? So how does this work? How does this egress protection mechanism work when the penultimate segment endpoint is several hops away?
So we have the flavor PSD here, right? When the node P2 received a seed with the
so
PSD.
let me interrupt there. Assume that the SRH does not have A2::1 in this example. How does egress protection work in that case?
Sorry, let me see.
Assume that, correct. So assume that the penultimate segment endpoint was A1::.
You mean P1? A1.
Yeah, the P1 router is the penultimate. Yes, it can be, right?
Yeah. Yeah, you are correct. Yeah. Yeah. So thank you. We should correct the problem.
So a second. Yeah. So please see or work out how this works. Second thing is, how does okay, let's say it is P2 and it detects that P1 node, P3 node is down, right? Now P3 node is down. How does it know that that particular behavior was an n.dt with PSD? Because PE3 is in the overlay, but P2 is an underlay node. how would it learn that the next SID is of this flavor and that it should do this, funky behavior to, bypass or skip that hop and go to the next one with all the encapsulation and all of these things. So how would it know?
You're meaning how P2 know, right? How P2 know?
How does P2 know about the overlay SID, which is this n.dt with PSD? How does it know about that, number one? And how does it know that PSD is the behavior associated with that SID when it arrives at P2? No, yes, I meant a failure condition. I meant a failure condition. Yeah, it could be, it could also be a, yeah, but it could also be true, but that, okay. Okay, so this is assuming that the okay, I think in the interest of time I can
And so
take
we are going in
next.
rounds, and
Yeah,
I
we'll
don't
go
see
to, I'll take it to
clear
the
answer. Keaton, please send your questions to the list, and we'll take it from there.
Okay, so thank you, Charles.
To all authors of the draft, please make it a priority to answer because you actually didn't provide any answers.
Okay.
So I'm final. I present for Sibo Hu. So I'm going to present SR physics midpoint protection. Next page. First, we would thank all who give us comments and suggestions. So as suggested, we present this draft in the Spring group, and we also initiate the discussions in 6-man mailing list. So basically, we focus on transient node as a repair node, which cannot change sigma routing header. So originally in the document, we have a section to talk about transient node as a repair node. So in fact, this is not in complying with RFC 8200. So we address that. We remove this section, transient node as a repair node in our draft. And we also address all the other comments. So in the current version of the draft, I think we are ready for adoption. So because this one is also experimental. So next page. So we would like request for adoptions. So any comments?
Have you confirmed that your changes are acceptable for Spring and 6-man?
Yeah, I think so. I think in the mailing list, we told them we will remove this the transient node as a repair node. So right now, only endpoint node can change, segment routing had basically changed the destination. So those one violate.
How the packet is encrypted? You have an extra layer of encapsulation, or you are changing the SRH header? It's not clear.
No, not change the SRH header, just change the segment left. This one right now, because we have a segment list. So when one node fails, so the endpoint node upstream anywhere. So in previous hop, and then that node knows, oh, this one failed, not reachable. We just pop up that one, decrement the segment left, and then we go to the next one, right? So that's a very simple change. It's not finite RFC 8200. It's a simple change. It's almost the same as segment routing behavior. It's the same as segment routing behaviors. So just now at the endpoint. Originally, we have a protection on the endpoint node, also transient node. So it's transient node violated the RFC 8200. So we remove that one.
If you only decrement the pointer, what if it's gonna cause loops? You only have the next hop, right? You actually skip the failed one. You go to the next one directly, but you cannot guarantee there is no loop.
Well, that one, yeah, that's a good question. So in fact, that's after IGP convergence. After IGP convergent, so we use we use the endpoint seeds. So we go along the shortest path of IGP after IGP convergence, right? So that's the solution. So the shouldn't have a loop because after IGP convergence that it works.
IGP convergence is slow. There's significant delta in time where you have failed link to the next hop, but your IGP hasn't converged yet.
Yeah, good
right?
question. So basically this solution have two stages. One stage is that before IGP convergence. So before IGP convergence, and then the package will deliver to the adjacent node of that failed node, right? Because one node failed, IGP not convergent. So the forwarding table on every node still think that node is not failed, right? Only the adjacent node know that node failed because he has a BFD detection, whatever fast detections. So that adjacent node will do TI, LFA, whatever FRR. So that adjacent node fastly detect the failure of that guy and then get around that failed node. So that's before IGP convergence. So after IGP converge, then every node knows, oh, that guy is died. So the remote node will know I cannot reach that failed node. So in this case, this second stage, the endpoint node will pop up that failed node, seed of that failed node, and then the next hop seed along the SR path. So that one right now is converged shortest path, and then there's no loop, right? So at the second stage.
So you're assuming you'll be preempting TILFA on local node by changing the list on not before?
No, not changing the list, just pop.
Yeah, I understand.
Yeah.
I couldn't put my hand up on the tool because the network's not working in here for me right now, but Darren Duke, Cisco Systems, I don't think that particular change was discussed on any mailing list, because if you say you're just gonna ignore the next segment and decrement the segment list without caring what it was, you're just gonna break it. You can't do that.
I think this we send to the segment list, and then we have a discussion recorder I can send to you.
Yeah, that aspect. Okay.
Yeah,
if you did, send that out very clearly, and I'll reply.
I can send to you. I think the other versions of this document collect all the record of mailing list. Yeah.
So you updated the draft, and you assume that the update has addressed the comments, right? But you actually didn't get any confirmation that people are happy with new changes, right? So I would really advise you to send another email to Spring with the updated version of the draft and explicitly ask whether people are okay with it.
Okay.
And then we can talk about adoption.
Okay, thank you. I will do that. Okay, we'll send this update draft again. Okay, to see what further comments. Okay, thank you.
Keaton, you want to ask a question?
Ketan Talalikar, Cisco. Again, it's kind of the same first question that I asked previously. There seems to be an assumption that with SRv6 that the penultimate or the previous segment endpoint node is directly connected to the next segment endpoint node, such that it can detect failure as in a TILFA or a local thing. This is probably not going to be always the case. So I mean, I'm really wondering how practical or useful this is, or if it is only applicable for a hop by hop kind of a path, right?
So regarding to your question, so this is not assume the node is, I mean, the endpoint node is directly connected to failed node. So this draft is allow a node, endpoint node is upstream of the failed node, can be multiple hop away. It can be the endpoint node directly connect the failed node, that's okay. It also allow the endpoint node, which is the upstream of the failed node, multiple hops away. Both cases is covered.
So
I don't believe the draft. Yeah, I don't believe the draft covers this. So, but yeah, sorry, Jeff, go on. Please.
So your assumption is that every node participating in IGP will flat update information, and the node that is the previous hop in the list will react accordingly?
Yeah, the different. So in each case, whether in case of the node, endpoint node direct connect adjacent the failed node, also the endpoint node is a couple hops away to the failed node, those are work. Because the endpoint node, after IGP convergence, endpoint node knows that I cannot reach the failed node, right? Because that node is down, IGP converged. After this endpoint node knows that I cannot reach the failed node, I will pop up the seed for that failed node. And then the next seed will be the first, at the top of the same list, right? And then we'll forward the traffic to the next seed using sorted path after IGP converged. So it's okay, right? Logically, it should be okay. So if we have any doubt, and then we can discuss on the list or whatever, right?
As Darren suggested, this behavior needs to be discussed in Spring.
Yeah, we can discuss. Yeah, no problem. We can discuss whatever issue you can come up or raise. We can resolve it.
Just a short follow-up. Huemo, whatever you discussed, it would be good if you put it in the draft before you send it out for review. So this way, people have the right expectation on what kind of, how fast the protection mechanism works. Thank you.
I think this idea also we present in the last IETF. We have a picture there, and then these two cases I presented there in the last IETF, because last IETF was printed in the spring, and then last IETF presented here. So as your question, I can present again in the spring, whatever, get more comments. That's okay.
So you've updated the draft and you significantly changed the logic, right?
No, not significant. Just remove this transient node as a repair node.
Which is significant change in the logic. So again, without going in rounds, please do address the comments. Please have a discussion in Spring in 6 months.
Okay, we can go back to Spring again. Okay. No
Thank you. Robin is going to present remotely, right?
We have a different presenter.
Hello everyone. Good afternoon. This is Qiangzhou on behalf of Zhen Bin to give a representation of the generalized IPv6 tunnel. Okay, next. So why we need the GIP, generalized IPv6 tunnel? Because currently there are many types of IP tunnels, such as you can see the list in the left table: GRE, IP, L2, TP3, electro. And on IPv6 network, it's hard to define extensions for all these tunnels to support the new features. On the other hand, it's not recommended to extension new features based on the IPv4 data plan for these tunnels. New features such as the APN and the alternate marketing and the IOM, etc. Okay, next. So what's the challenge? If the existing IP tunnels need to be supported new features such as the previous before, and so the following problem will be exist. First is a lot of standard work. All of the IP tunnels mentioned above need to be extended accordingly, resulting a lot of standard work. And the second is it's hard to keep the consistent because between the IPv6 and IPv4 for these IP tunnels, since the possible extensions are recommended to be only on the IPv6, so we can't keep the consistency. And the third is function reduction. IPv6 can directly support some functions of these IP tunnels, which can't be done with IPv4. This means some function becomes redundant over the IPv6. For example, VXLAN takes use of the UDP to do the SMP, but in IPv6 VXLAN, the flow label in the IPv6 header also can be used to support the SMP. And fourth, the difficult to extension based on the existing format. Some IP tunnels such as VXLAN and GRE have their own headers. If these tunnels need to support new features over the IPv6, they will face the challenge of the choice between reusing the existing IPv6 encapsulation for this new feature based on the IPv6 extension header and define a new extension based on their own tunnel header. So there are two problems. The first is if the tunnel header is extended, it will be redundant with the existing IPv6 encapsulation for the new feature based on the IPv6 extension header. And the second is for some existing tunnels that don't have their own header. So they have to reuse the IPv6 encapsulation for these new features based on IPv6 header. So extension need to be redefined in the IPv6 extension header. As a result, the extension may different from that of the IP tunnels, which have their own headers. Okay, next. So we define a new tunnels called generalized IPv6 tunnel, and the tunnel is defined to use the IPv6 header and the IPv6 extension header to support both existing IP tunnels function and the new features. And the encapsulated packet has the following format. Okay, with IPv6 header and IPv6 extension header. And the next is the payload packet. This is option 1. And the next option 2 is IPv6 header and IPv6 extension header. And then is the existing IP tunnels table header. And then is the payload packets. Okay, that's one. So give an example of VXLAN. The function of the UDP is replaced by the flow label of the IPv6 header in the GIP6 tunnel. To ensure capability, the value of the flow label calculated for the purpose of SMP should be the same as that of the source port of the UDP. And two, the definition of the VN option is defined, and this includes the VXLAN header information, and the VN option must only be encapsulated in the destination option header. Okay, next. Okay, for quick is also an example, and we define a new quick header, and the quick header also to define to carry the quick header information. The quick option and also you also can encapsulated in the destination options header. Okay, next. Okay, and for MPLS, we just give a use case use for the GIP6 for MPLS. Next. And what's the challenge is this? MPLS have 4 challenges. First, the MPLS is lack of the source indication and MP to P connection may occur. So this will cause the difficult and complex when process the OM of MPLS. Although SFL is defined, but there is few in implementation. And the second is the payload type can't be directly determined because there is no payload indication. And third, there is no metadata extensibility and it's difficult to encapsulate new folding attributes for the new feature, such as affiliate, selection, and APN, etc. And 4 is the process of the SMP function is complex and affects folding performance. Intro pay label is used for the SMP, but it is at the top, at the bottom of the label stack. So the internal IP header information have to be passed for the purpose of the SMP. Okay, next. So when you use the GIP6 tunnel for MPLS, we can have the following advantage. The first is the IPv6 source address can be used to form a source identification. And the next is the IPv6 net hop header can indicate the payload type. And the third is the IPv6 flow labels can be used to implement the SMP. And fourth, the encapsulation for the new feature can have to be defined well in IPv6 and can be reused easily. Okay, the right is the format. Okay, next. Okay. So we have 2 types for MPLS ID, and here is the first. And first we have 2 actions. One is to pop, and one is swap. If it's pop, we just shift the beach. Okay, next. And for the type 2 MPLS seed, and we use the IPv6 routing header, and so use the label stack. Also, we define the seed is defined to host multiple labels encapsulation. This is also the same as, and the type 2 is used as a segment as routing header. After all the label encapsulation in the IPv6 destination address are hopped. So maybe the first label encapsulation in the segment indicates the SL of the IH will be processed. Okay, next. So also have some control plane consideration. The first is the existing MPLS control plane doesn't need to be changed. So MPLS label on the control plane can still be distributed for IPv6, IPv4, and L2. Next. Okay, so next is some requirements of the GIPv6 tunnel. And so first, they have 2 problems. The first is currently many new features are emerging and corresponding encapsulation over the IPv6 and as defined. And the second is in the process of deployment of these new features, because network devices have different capability of IPv6 extension header. So the following issue maybe have okay, maybe you can check this. Okay, next. So we have some requirements. The first is the way to advertise the capability, and maybe the 2 different ways. One is use the IGP, BGP, SPF, and the next is use the controller. So BPS and the NetConf may be used. and inter-domain. So the path can across multi domain. So this time we can use BGP to support this scenario, and the TCP or BGP can extend it. Okay, next.
30 seconds.
Okay. And you can, and the capability about the IPv6 extension header and the capability option of the header also we need to extend it. Okay, next. And the last is the capability about the specific feature like slicing or alternate marking, IOM, APN, etc. Okay. Okay, that's all. Comments are welcome. Thank you.
Greg?
Greg Mirsky, Ericsson. Well, thank you for sharing your imagination. I have a question. So, are you aware of the work on MPLS network actions to extend MPLS architecture?
You mean the extension MPLS?
It's not extension. It's called MPLS network actions.
I'm not. Don't do that.
Okay, I will encourage you to check the work of MPLS, Pulse, and DetNet user working groups and the documents they adopted already, and not to duplicate it elsewhere.
Yeah, but I think that is not conflict.
Since you are not aware of this work, I don't think that you can really compare your proposals and what the community is working on for some time.
Okay, we can compare.
Okay, so I don't think that what you are proposing really is required. Thank you.
Darren Duke, Cisco Systems. This one's maybe more for the working group chairs. This draft is defining a bunch of new tunnel encapsulations. Is this the right location for this type of work?
Yeah, so there's a set of requirements, and usually requirements are there because someone requires them. I'm yet to hear from NVO people they aren't happy with the transport layer used for load sharing or load balancing. So, you know, there are billions of endpoints doing VXLAN or IPv6 today, and they're using UDP. Right. So the cost of implementation, what you're proposing, is enormous, and benefits are absolutely unclear. Whole use of flow label for load sharing is, you know, toxic topic. So in general, I mean, I understand what you're trying to do. I'm not sure industry really needs it, and you definitely need to go to all the stakeholders, start with MPLS and NVO, and tell them what you are doing, and here's their reaction to it. If they don't need it, maybe you shouldn't be doing it.
Okay, we can discuss later.
I think there's a couple of people. AC?
The long road to the mic. AC Lindum, Cisco Systems. I think this is interesting that you've taken like a greenfield and mapped all these existing end caps to IPv6 routing 100%. It's a nice exercise. It would be a nice like research paper. But given how long all these things have evolved and been deployed and where they are, it's something, I mean, it'll never see the light of day. I can tell you that right now. So you're just spending a lot of time, especially with the scope. You know, it might be if you had an, I'm not saying you do, but if you had an end cap that tried to replace those, that would be one rather than mapping every one of them. And you still have all the different cases because you really haven't gotten rid of, you know, you haven't got rid of Genève or MPLS or anything else. You just mapped them. And it's, you know, like I said, well, it's kind of nice to do a greenfield. It's not, it's just never going to happen.
Okay, I think the advantage for this method, we maybe even we also have many header to do, but the header, the format may be at the same format.
So to rephrase AC, you know, if you would have focused on completely new use cases, maybe there's a value, but looking at what you're trying to do, it's just ocean boiling exercise. Yeah.
Okay.
We're done, right?
Yeah.
Thank you.
Okay, thank you.
Mike?
Okay. So if AC thinks the previous draft will never see the light of day, he's going to love this one. So this draft is a little bit unique in that we're not proposing anything. We're simply giving a summary of what we've seen being proposed out in the industry. The authors, we're involved in the IIC and a little bit of some of the IEEE groups that are working on blockchain with regards to IoT and governance. And so, and we presented here previously on the impact of DLTs on the network and some measurements and testing we've done. So this is kind of just an evolution that we've had. It's probably too experimental and forward thinking for IDR, Sue, and CIDR. So we're just gonna start here and see where it goes. And we probably could have changed, probably could have called it append-only ledgers for BGP, but blockchain's much more provocative and gets people upset. So we're gonna just go for this. Just in one slide, I wanna just cut to the chase to tell you what we've found, and then I'm gonna meander a bit, and then we'll come back to it. So just wanna make sure that everybody's clear as possible on ways that something like a blockchain could be used for a routing protocol like BGP, although it could be used for probably any routing protocol. So a DCS, a distributed consensus system that uses something like blockchain, it doesn't have to be blockchain again, but a lot of us are getting more familiar with that. Could it be used out of band, something like RPKI does for BGP to supplement existing BGP management, but perhaps by using smart contracts. So smart contracts are if-then programs that are stored on blockchains to run when predetermined conditions are met. So like if Bob signs a document and that's sent to the blockchain, then the smart contract would initiate payment or a transfer of a particular asset. So it automates those agreements. So a BGP related smart contract could be executed immediately when some condition, such as receiving an update with too many prepends or some sort of a hijacking is detected. And so the action could be to deny an update after consulting a blockchain that you've created. It could be something as simple as using blockchain to securely store config files or ROAs. Maybe the IRRs could use blockchain to store these before they distribute the ROAs. And we dealt with that in the draft as well. Tools do exist to do this today, but a blockchain does have potential advantages in that it's transparent, it's immutable, it's secure. It could be used globally or within the domain. So that's kind of cutting to the chase. It just kind of gives you an overview. Let me meander just for a little bit. Next slide. So there's, as I mentioned, a variety of proposals that have been happening. For those of you that may just despise talking about blockchain in the IETF, it is starting to infiltrate the IETF. There are some potential working groups, one involving secure asset transfer between blockchains, being able to provide interoperability between blockchains. It very well may become a working group. I'm not sure if that's happened or if that will happen this week. And supply chain integrity, transparency, and trust, which is also based upon a append-only ledger. So there are proposals happening. We've received, as I said, questions about how DLT in networking could be handled. And so we've been discussing that in some other forums. We did hold a side meeting to discuss this a couple IETFs ago. This IETF, there was a networking in metaverse side meeting. and blockchain and metaverse work hand in hand, so you can know who owns what in some sort of a metaverse. This is just an informational draft. It's not an endorsement, and we're not, again, asking for anything except for advice as to whether this is something that we should be working on in this working group or elsewhere. And it asks the question, is it possible to use a distributed consensus system like blockchain to manage BGP? And the answer is yes. Whether it's a good idea or not, that's another question. Next slide. So let me fly through these ones real quick. If you're not familiar with DLTs, then you just kind of have to get it on your own. But cryptocurrencies and DLCs, they don't care much about the underlying provider network. They just assume that it works. They have their own peer-to-peer networking with a pool of transport layer connections. And they've done a pretty good job of securing their application. Next slide. This is what basically their view of it is that they have this peer-to-peer network with many nodes. Sometimes it's millions of nodes in the case of the global blockchain that are verifying transactions and executing smart contracts and things. And it just runs over this IP network. Next slide. This is the architecture that within the IEEE anyway, that we've kind of been using in most of the groups, where you have your session layer where the transactions and blocks are being created. Above that is the consensus layer where you're either using proof of work or proof of stake to create these blocks and the transactions that are in these blocks. And then the contract layer and application protocol layer and the application layer. Next slide. On my flight over here, I listened to a podcast, which I think is one of the best podcasts out there. My only argument is that they should have more of them, but it's Leslie Daigle's Tech Sequences. And this last one that they had, which was on cyber criminal gangs, at the end of it, they start talking about using blockchain. And so my ears picked up about how maybe, criminals have their own ecosystem. It's gotten very professional, even accepted. And blockchain could potentially be used as a base for the good guys ecosystem to help counteract that. Because blockchain will help show proof of where criminal activity is occurring. It'll make the bad guys expend more effort than perhaps intelligence gained. And the whole idea of blockchain is to make it publicly visible, and perhaps we can use that to our advantage. Next slide. You could use a regular database like a SQL or NoSQL database to do these kind of things, but these are some of the potential drawbacks that they are controlled by administrator. They are client server in nature. Malicious actors can more easily alter the data than you could on a blockchain. The administrator decides which data is accessible and visible. The good thing about them is that they're easy to implement and maintain and very fast. Next slide. There's a lot of opportunities outside of using it for BGP, including trusting capture packet data. So if you're capturing data from your network, you can maybe store that on a blockchain because you may trust that more. And a variety of other opportunities as well. Dino has worked on this with regards to Lisp. He worked with the Nexus community, and he used Lisp to help DLT applications to find the best nodes. Okay. I'm gonna skip this one, go to the very last one. So how about just look at that diagram right there, and I'll end on this. It's that kind of very similar to RPKI. You could have BGP clients that are also utilizing a distributed consensus system, which may have a BGP block table in there, including smart contracts that they look to before they act on certain things. It's kind of similar to using RPKI. It could be a replacement for RPKI or an addendum to it. That's it. Do you have time for questions? Or?
Yeah, David.
David Lamparter. So a fundamental aspect of blockchains is that you have proof of work in some form, which can be proof of CPU usage, proof of storage, proof of stake. the way, or the actually only way I see this being useful is if you have proof of network ownership of something, where that something could be addresses or an ASN. Are you actively looking into making that the base of the blockchain, or are you still too early for this, or?
We're not actively really looking at anything except for what I just described. So, but very good point.
Jeff Haas, IDR chair, user BGP, a protocol everybody says is very slow to start with. And blockchain is not noted to be fast.
True.
So for your use cases, having this as part of the protocol control loops is probably not a great thing. I would suggest just simply taking those use cases, throwing them into the fire, and stay warm by that.
Fair enough.
But BGP also is about policy, and policy is about money. So places where policy can actually take things as input, whether it's people agreeing to announce this route after you've paid your bill and your bill's registered in a blockchain, something like that. That's a reasonable thing. People wanting to actually have their address delegation contracts move through a blockchain as a way of saying that they're transferring addresses. So people like Aaron and Ripe and other places obviously have their own systems. Maybe they're good targets for you to have this conversation. But mostly look at this as use cases, not as a transfer of centralized things that have to go through some sort of delegated infrastructure. PKI makes sense for a lot of what BGP does. For the things that are more provider to provider type relationships, that's not a bad thing.
Thanks.
Dina, 1 minute question, not more. Be quick.
Okay, I'll be very quick. I'm just going to respond to your point. He didn't say he was going to use BGP and have the RIB be in blockchain, because thank you for not doing that, because it is very slow. But it could be used for administrative things. And I was going to ask the same question, could be a good thing to prove ownership of address prefix that have been allocated by the registries. That would have some really good use.
Yeah, thank you. All right.
Mike, so please do think what you're going to do with this work. I mean, we're happy to give you an opportunity to introduce the work, but practically you really need to identify your focus and start putting more meat on the bones. Because otherwise.
Very good. If anybody's interested, please contact me and we'll go. Thanks.
Thank you.
Hello, do you hear me? Yes. Okay. So welcome to the Cyan update presentation. In this presentation, we are going to tell you. Oh, sorry. Okay, we are going to tell you what we have done since we were here at the IETF for the first time. That was at the IETF115 in Vienna. Next slide, please. So there were two events where we presented Cyan. There was a side meeting about Cyan where we gave an introduction and we asked you for input, suggestions about the Cyan IETF strategy. And there was also a Cyan presentation, a very high level overview on the routing area open meeting. And then we got a lot of feedback. We realized there is also interest, but people told us Cyan is really a very big system. And the IETF is not really good at big systems, but more at small components. So that's, we got the advice to try to break Cyan down in smaller chunks. And that's what we started to do, or try to do. Next slide, please. So what did we do so far? We have written and published 3 internet drafts. One is a Cyan overview draft. Here we try to explain Cyan a bit more in detail, and also a bit more per core component. Then the Cyan component analysis is also about the core components, but then more how they interact with each other, how much they are depending on each other, and also how much they use existing protocols, extend it, reuse it, or maybe not use it. And then the third draft is about the Cyan control plane PKI, where we already in detail give a specification about one of the Cyan core components. And we presented these drafts in several Penergy interim meetings. as a base for discussion. We chose Panergy because we do not have a home yet at IETF, and the path-aware networking research group seemed for us the most close. But we also want to share our work with you, with the routing area community, so that's also why I'm here. Next slide. Now I want to very shortly give you an idea what these three drafts are about. This SIGN overview draft discusses the motivations behind the SIGN architecture. It gives a high-level overview of the fundamental components, and it concludes with an overview of current SIGN deployments, because it is not only a theory, but really already in use. Here is the link to the draft if you want to read it for yourself. Next slide. So very short SIGN in a nutshell. SIGN is a path-based inter-domain network architecture. The three core components are the control plane PKI, which is working or responsible for the authentication, and which builds the base for the unique SIGN trust model. Then we have the control plane component, which is doing the routing in that it constructs and decimates path segments, and it authenticates path information. And then in the data plane, the path forwarding happens. And what here takes place is that here these path segments are combined into paths. This path information is put in the header of the packets, and the packet forwarding is then based on these path information. So the forwarding is based on the information in a packet and not routing tables. And that means that SIGN uses simple routers and a stateless operation. Next slide, please. As I already told you, it is really already in use, SIGN. There are several service providers in Switzerland, Europe, and also in Asia, which provide SIGN, and this is growing. There is an internet exchange point, Swissix, which offers SIGN peerings. And there are also customers working with SIGN, especially the Swiss financial institutions, the secure Swiss financial network, where the Swiss National Bank and also the Swiss Clearing Institute and the bigger Swiss banks are working together, sharing their data based on SIGN. Also education, government, as well as a healthcare network. Then also research networks, connect based on SIGN. And we have the SIGN Lab. This is more like a research testbed where we can try out new features. Next slide, please. So the SIGN component analysis is really analyzing the core components from a functionality perspective. It describes how they depend and interact with each other, outputs, properties provided, and it tries to answer the questions, what are the main components of SIGN, can they be used independently, and what existing protocols are used, reused, extended, or maybe why are they not used. And it briefly touches on the maturity level of components and extensions. If you are interested in this draft, here is the link. It's okay. Very shortly now, this dependency graph. On top, we have this control plane public key infrastructure, which is responsible for the authentication. This gets as input bootstrapping information, among others, some kind of trust root contract and loose time sync. And as the output, it delivers a SIGN trust model, which I will shortly describe later, and authenticated control messages. This is the input for the control plane, for the routing part. And then as an outcome, you have this authenticated path segments, which the data plane uses to construct these paths, which it puts in the path header. And the outcome then in the end is secure inter-domain multi-path communication. Next slide, please. So, and then our next draft is more like really a specification of this control plane PKI, which we think is the most independent part, core component of SIGN. It presents the trust concept and design of this control plane PKI. It provides a short overview of the certificates, keys, and the roles involved. It gives also detailed specifications of these building blocks, and it concludes with several considerations about deploying it. Here again, a link to the draft. Can you please, the next slide? So, and here is this trust model very shortly. It is based on isolation domains, ISDs. These consist of a logical grouping of autonomous systems that share a uniform trust environment, like for instance, a common jurisdiction. Each isolation domain is administered by several core ASs. They compile the ISD core, and this ISD core negotiates this trust policy or contract, which we call the trust root configuration. And then the certification authorities in an ISD, they can only create certificates for the autonomous systems in their own isolation domain. So you see also the picture, these are 3 isolation domains. They have their core ISD cores, and each isolation domain has also his own trust root contract or configuration. The next slide, please. So that was in a very short, fast tempo what we have done so far. What we are doing now is to address the received feedback, and we still welcome very much reviews and commands from you. Based on this feedback, we want to improve the existing drafts because they are really the very first versions of these drafts, and there is a lot of room for improvement. Then we also want to write the specifications for the other 2 core components, the control plane and the data plane. And in the meantime, we keep coming to the IETF, share our progress and thoughts with you, and we try to build up yes, support and a community. And yeah, that was it. Thank you for your attention, and if there are questions or any feedback, please welcome.
Okay, thank you for being here and sharing what's going on with SAN. So I believe you need to focus on 2 things. One is obviously specification, because if someone else is interested in building systems that can interop with your system, you need to clearly specify what you are doing, and IETF is probably the right place to do so. Number 2 is potential interworking between common internet run by BGP, SAN, and migration scenarios, tunneling scenarios, how you authenticate non-SAN domains, and so forth. And thank you.
Okay, thank you.
So we're done. Yeah. Thanks, everyone. We are giving you 3 minutes back, and we'll see you tomorrow.
Hi. Just a question, would it be possible to use the smartphone to click slides while presenting?
I think so.
Because there's this